Okay, here is what happens with global warming in the atmosphere. Global warming here is defined as adding carbon dioxide to the atmosphere. Let's take a look. Here is the surface, and we're going to be measuring at the surface with a spectrometer to measure the infrared radiation that's emitted by the atmosphere, and we're going to consider only an atmosphere with gases in it for the moment to illustrate especially the effects of carbon dioxide on warming in the atmosphere. Okay, so now here is a spectrum measured with a spectrometer at the surface, a calculated spectrum. It's very much like what we get when we do the measurements. And what we can see is that in the atmospheric window region from about 800 to 1300 inverse centimeter wave number, we have minimal radiation, and then in the 600 to 800 range, that is the region of the atmosphere where CO2 really has a strong impact on the radiation budget for the Earth. Now, the curves that you see outside of this calculated curve that's shrugging back and forth, these curves are for theoretical black bodies at different temperatures. For example, if we look between this purple one here and this blue one, purple one's at 260 degrees Kelvin, the blue one's at 280 degrees Kelvin, so at about 270 degrees Kelvin. There is a pretty good fit to the envelope of this calculation in this spectral range in here. And that's because the emission is strong by the gases in this spectral range, meaning that in this spectral range in here, then the infrared radiation is coming from fairly close to the surface as well. Now, what's going on here with this shrugging? Well, this is the spectral range where CO2 contributes a lot to the infrared radiation coming to the surface. What I've done in this calculation is to say, okay, let's start off with 400 parts per million of carbon dioxide in the atmosphere, and then let's double it to 800 parts per million in the atmosphere, and see what happens to the shape of the spectral curve here. So what we see is that initially the shoulders are down, and then they go up. And that extra radiation is given, that comes about with the 800 ppm, is shown by this extra amount, like in this region in here, this region in here, this region in here, and a little bit in the atmospheric window region. So what happens at 400 ppm, we have about 207 watts per square meter coming from the atmosphere to the surface. When we double that to 800 parts per million of carbon dioxide in the atmosphere, now we have about 209.9 watts per square meter, basically 210 watts per square meter. That's about 3 watts per square meter difference when we average over all of the spectrum of infrared radiation coming to the surface from the atmosphere under those two conditions. And so in a nutshell, this is very much the effect of carbon dioxide on the radiation balance of the Earth. It's a very direct, calculable, and measurable effect. There's nothing mysterious about it. The mysteries all are associated with the way that the atmosphere responds to this kind of direct radiative forcing of the surface, where we provide a lot more radiation to the surface. When the surface gets about 3 watts per square meter extra of radiation, well, the surface is going to be warmed, and so that is going to make it emit more infrared radiation from the surface up. Remember, this is from the atmosphere to the surface. There's a similar calculation that can be done at the top of the atmosphere, or looking at the radiation that's going out as well.